Okay, we're going to be talking about synthesis reactions this week. And synthesis reactions you would have learned a little bit about in grade 10. So, this is where you have an element plus an element yielding a compound. And how we're going to be able to recognize synthesis reactions is that you will only ever make one product. Now, it gets a little bit more complex. It's not just as simple as an element plus an element yielding a compound. Sometimes we can have these special case scenarios where you have a smaller molecule plus another smaller molecule yielding one bigger compound. So we're going to take a look at some of these more advanced cases as well. So let's go and take a look below, and we'll do a few examples together. Then what I'm going to ask you to do is to complete the rest of the chart or the sheet and check your answers with the answer sheet provided. So let's take a look. Here we have copper plus sulfur. So here I'm going to write down Cu and S. Now I want to watch out for my Hofbrinkels. My Hofbrinkels are those elements that when they are by themselves, they have to exist as a diatomic molecule. So I'm going to just write down Hofbrinkel. And so that means hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. When they are by themselves, they must be written as H2O2, F2, Br2, I2, N2, and Cl2. Neither of these, copper nor sulfur, are a Hofbrinkel. So we just write the element symbol as Cu plus S. In this case, they're telling us that we are making copper 2 sulfide. Copper has more than one valence option, but they're telling us to pick the 2. So I'm just going to write the valence of 2 up above, and then sulfur. When I go to my periodic table, I see that sulfur has a charge of -2. When I crisscross, we just get Cus because those subscripts will have reduced. When I go to balance, it looks like we have one copper, one sulfur, perfect. Now, what rule is this one? This rule happens to correspond with rule number 1. It is the direct union of two elements to produce a binary compound. Binary meaning only two elements come together to form that compound. So I'm going to just write down beside this example that that was rule number 1. Let's take a look at the next one. Calcium oxide plus water. So calcium oxide is Ca and oxygen is O. When I look at the valence of each of those from my periodic table, calcium is a +2, oxygen's a -2, crisscross, just CaO, plus water. What I'm going to do is I'm going to write water as H2O, okay? And I'm going to take a look, what does this rule look like? Even though they've given me the answer up here for the product that I'm going to be making, I'm going to see what rule this looks like up above. So calcium oxide plus water. So is that a metal oxide plus carbon dioxide? Nope, because I'm adding water. So that's not rule 2. Rule 3 is a binary salt plus oxygen. Nope. Rule 4, a metal oxide and water react to produce a base. That is a metal oxide. Calcium is a metal and it's with oxygen, so that's a metal oxide plus water produces something that's a base. Anything that has hydroxide in its formula is considered to be basic. So that makes sense. This happens to be rule number 4. Now, here we go. Calcium hydroxide is one of our polyatomic ions, so I would go look that up. Calcium is a +2, hydroxide is a -1. We crisscross, and the 2 comes outside. When I go to balance, one calcium, I've got 2 oxygens on the left, 2 hydrogens, and that happens to all be balanced. Now, if I needed a little bit of help, I can also look at the reaction examples that are provided that also correspond with the rules. So number 4, there's sodium oxide plus water yielding sodium hydroxide. In this case, we happen to be using calcium. Okay, let's take a look at example number 4, hydrogen plus chlorine. So hydrogen, remember it's one of our Hofbrinkels, so we have to write it as H2. Chlorine is also a Hofbrinkel, Cl2. This happens to be the direct union of two elements coming together, hydrogen plus chlorine. Now, when we hook up hydrogen and chlorine in a compound, we go back to their original valences. So I'm not going to write down H2Cl2. Nope. Hydrogen, when it's in a compound, has a valence of 1. Chlorine has a valence of 1. We crisscross, and it's just HCl. I'm going to balance. I need to put a 2 out front here. So we call this hydrogen chloride. So I'll just write that down as my product name. So that, again, just corresponds to rule number 1. Number 5 and 6 are also rule number 1. Okay, let's do a couple more together. So I'm going to flip over onto the back. And you're going to see that number 10 through to 17 are some more special case scenarios. So let's take a look at number 10 together. Here we've got magnesium chloride plus oxygen. So we need to take a look, what rule does that look like in order to predict our products? So here, when I take a look at magnesium chloride plus oxygen, and I may want to take a look at some of the examples provided. So we look at rule number 1 has plus oxygen, and we have rule number 3 plus oxygen. Okay, and let's see which one does this best match. So is this the direct union of two elements giving a binary compound? No, because I have a small compound plus another small compound. So I'm going to look to rule number 3. Binary salts plus oxygen react to produce chlorate. So if I look here, KCl, oh, that's just like my MCl. 2 plus oxygen yields potassium chlorate. So it looks like the binary salt plus oxygen yields the metal chlorate. So let's finish this one here. Magnesium chloride plus oxygen is going to yield magnesium chlorate. Now, chlorate is one of our polyatomic ions. That you're going to have to use your chart to look up. Chlorate is a -1, it's ClO3. Magnesium is a +2. When you crisscross, you get MgClO3 bracket 2. And then what we're going to do is we're going to want to balance. 1 magnesium, 1 magnesium. We have 2 chlorine, 2 chlorine. That's fantastic. We've got 6 oxygens on the right, only 2 on the left. So we need to put a 3 there. So there is the predicted product there. When it comes to P2O3 plus water, so what rule is that? So we established that this one was rule 3. Here we have some sort of oxide plus water. Let's take a look. Is that a metal oxide plus water, or is it a non-metal oxide plus water? Metal oxides, well, phosphorus is a non-metal, so that would look to rule number 5. A non-metal oxide plus water reacts to produce an acid. Now, if you look through the slides, I give you some of the acids that are created when non-metal oxides react with water. So you can use the module slides to assist you as well. So in this case, when P2O3 plus water come together, we get what's known as phosphorus acid, and that's H3PO3. Now that's just something that you would have to take a look at through the module slides to know that. Okay, so when we go to balance this, this is the acid that is created, and often with an acid we'll put AQ, so we know that it's just not hydrogen phosphite. We just put AQ, so we know it's phosphorus acid. I'm going to balance. We've got 2 phosphorus there. We've got 1 there. So we'll put a 2. And then in terms of the hydrogens would come next. We've got 6 there. I'll put a 3 there. And then we've got 3 plus 3 gives me 6 oxygens. We've got 6, and that's all balanced. So here I'll just put down, so you know, phosphorus acid. And that happens to be rule number 5. Okay. What I'd like you to do is complete the rest of this worksheet and cross-check your answers with the ones provided online.